Hi and welcome back. In this next video we're going to look at optimizing your take. This will include processing any gaps in the data and removing any noise. So the first thing I need to make note of is that this is the whole range of motion, and the example you'll find in our sample data is just a small section of that. So some of these examples may not be present in the data you've got, but I'm still going to show you how to fix them anyway. So the first thing we'll notice here is a large chunk of red where a marker has been dropped from tracking. This is a fairly standard issue that we'll come across, and we can see it's here during the sucking in of Leanne's cheeks during the range of motion, and the marker comes back, or the detection comes back, but it's not been associated by the tracker. So all you have to do is go to the frame where the marker comes back, make sure you've got your marker selected. So in this case we've got right dimple selected, and simply select the two detections and press M, and we can now see that the marker's been reassociated, and we can now track forwards for that marker, like so. Now, as I've already mentioned, if you track forwards with a single marker selected, it will only track that marker, but it will track a lot faster. Okay, so as you can see, I actually cancelled the track forwards then. Now, you might have noticed already, but the tracking process goes forwards and then it goes backwards, and the time bar will slow down towards the end. Now, it's perfectly okay to cancel the backwards part of the tracking if you so wish. That's what I did, just to speed things up more than anything. So we can see that our right dimple marker has been tracked now for the rest of the range, and we're left with a gap here across the data. Now, there's a few things we could do to fill this gap, but in this situation, because the markers are disappearing quite a lot, there's really not much there at all. Probably the easiest thing to do would be to use an interpolate fill. Now, to do this, we have some options under our properties. So if we go to gap filling parameters, we can either overwrite existing gaps. We want to turn this on in this case. We can use forward prediction, or we can use backwards prediction, and we can allow a single camera or a single sensor to track the gap. Now, for this example, I'm going to turn off single camera tracking, and I'm going to keep forwards and backwards prediction on. Now, what this will do is it will look forwards and backwards when it's filling the gap, and you'll get a nice smooth interpolated fill across the gap. And now I'm also going to turn on overwrite existing gaps. The other thing I could do if I didn't want to turn that on would be to remove the existing interpolated data here, and to do this I simply go edit menu, remove interpolated 3D points, and you can see here it's removed that data for me. Now, the interpolated gaps fill is a fairly automated process. It's under the process menu, and with the marker selected you just run interpolate gaps. Now, there's only one gap on this marker, but we'll see that the results are pretty good. So here we can see the marker, and we can see the job it's done now. Like I said, we're going to get a nice smooth intro and outro to that marker, which is really good. And if we turn on projections in our 2D view, we can actually see the reprojected fill across the 2D image. So we can see it's pretty close, and we're pretty happy with that. Okay, so that's what happens if you want to add an association because it's dropped one. We're now going to look at a single camera gap and show you how to use a target track to fill that gap. Okay, so the marker I'm looking at here is the left inner jaw. Now this example will be in your sample data, and what we can see here is that a single camera has been used for a small portion of the gap, but it's actually quite noisy. Now we have the option to remove this noise by selecting the range across the gap and using view set active range start or control 1. We can set an in point, and then we want to go to the end of our gap, which should be here, and I want to set the active range end, or control 1 and control 2. Now I can remove detections across this point, so I just go edit, clear selected, active range, and if I only wanted to use one camera channel, I could use detections, but because I want to delete the range across both cameras, I'm going to choose clear selected, active range. And here we can see it's created a nice clean gap for us. So if I press Control 3, I can reset my selected range, and what I'm going to do is go to a point in the middle here where we can see the marker position, and I'm going to go edit target track or Shift E. Now because I've got my left inner jaw marker selected, what that's going to do is allow me to click in the middle of my marker and basically add a keyframe into the data. Now by setting the blue square here, I'm specifying the size of the marker, or the size of the point I want to track, and these green lines specify the area that I want to look for in terms of tracking from frame to frame. So I've placed one in the first camera. Now again I just press Shift E and add it into the second camera. You can see it's not quite as visible in this camera, but it should be okay to track it. So I select my blue range, and you can see here I've basically given a hint to CaraPost where the marker should be during that gap. And what I can now do is I can track backwards using Control Q, and it will track the point backwards, thus filling the gap for me. So this is a really useful way of filling gaps if you know that there's some useful information there in the camera view. So it's basically used a target track to give a hint, and then we've used patch tracking to fill the gap. And again here I can just do Control W and track forwards, and this is going to track my gap forwards. Like so. And again we get a nice smooth fill across our marker as the points come back in. Like so. So that's a way of using manual target tracks to help fill gaps. Next we're going to look at how to fix noisy parts of the data. Okay, so noise in your data can be caused from a number of issues. One issue could be external light sources, shining light across your subject's face, which can cause the size of the blobs to change, which can give you increased noise. The other common cause of noise is bad contributions across cameras. Now a bad contribution is any camera, let me turn off projections, that can see a marker but just see it on the edge of its view. So the marker will kind of go in and out of kind of being in a good view and a bad view. So here's a good example. The right cheek marker here, we can see it's right on the edge of the face. And if we select this marker, we can see an awful lot of light blue. Now light blue is fine in some situations, but here where we've got two good cameras contributing already, this light blue is only going to introduce noise to our data. So let's see if we can spot any. it's quite hard to see, but generally if you've got good cameras contributing, you can remove the bad ones. So in this case I'm just going to remove channel 1 for an example. So there's this camera, you can see like both of them, they're right on the side of the face. So to do this I just select the point and I'm going to use edit detach detections active range. Now you can either select your channel that you want to remove, so in this case it would be 1 and 0, like so, and go and remove it from here, and that's removed it from these two cameras. Or we can just simply select the marker and Ctrl-Shift-H in each camera view to remove it. And you can see here those two cameras have dropped their contributions, but we're still going to get good data from these existing two cameras. So that's showing you one way to clean noise if you have some in your data. In the next step, as an example, I'd like to show you what happens when you have two blobs merging together. Now this is not such a common issue, but you'll still find it happening, especially around the lips, for example. As your lips curl out, markers can sometimes get merged together. But just as an example, I'm going to show you here, we can see a blob's been drawn across both markers. Now during our initialization process we decided not to include this camera in the contribution, probably for the right reason, but as an example I'm just going to show you how we could fix it if we had. So I'm going to select my marker and I'm just going to manually add in a detection here, and that's going to be this marker, and then I'm going to do the same, so Shift E and add in a manual detection here, like so. Okay, now normally in tracking, even if these markers were far apart and then get closer together, at some point they'll merge and you'll see a jump in the data. But there's a parameter we can use to stop that happening, and this parameter basically looks at the size of the blob between frames. So if you imagine you have two blobs coming together and they're the same size, then all of a sudden it gets bigger. This parameter will stop the system from using that jump in the size of the blob. This parameter is under tracking parameters and it's blob size different threshold, and I find changing this value from 0.75, which is the default, to something tiny like 0.01 will mean that when we come to select our point and we track forwards, rather than use the blob that's already there, it will just use the manual target track or the patch track that we gave it. Now if we hadn't added a manual target track, it would automatically use a patch to track the data. So here we could see two markers, two markers, two markers, it jumps. Now by changing this blob size difference threshold, because the size of the blob jumps too much, we're not actually using that information. So we're getting two blobs that are being tracked very close together. So from my experience, this is something you can do once you've tracked your data initially. So you would track the data using 0.75, and then you may find in a single camera view that there are two markers that are getting too close together, but you actually want to use this information, so you would delete the detection from that merging camera view, add in your manual points, change the parameter, and then run the tracking again using just the selected markers to speed things up. And what that allows you to do, as you can see here, is have two very close together merging markers essentially. Well, they don't merge, that's the good thing about it. Okay, so that's showing how to fix blobs that merge together. Finally, I'd like to show you what to do with a single camera track. Now, this is a bit hard to demonstrate because single camera tracking is actually used by default unless you turn it off down here in your gap filling parameters. But a single camera track is basically shown in orange, as you can see here, and we can see that there's just a markers kind of coming in and out during tracking, like so. So it's going from blob to patch tracking, which is fine. That's what we want really. But what the system can do is use this single camera to create a kind of 3D, pseudo 3D from the data. Now this is all well and good, but what you may find is sometimes there can be a pop in the data or a jump in the data when a camera tracking goes from one camera to two cameras. The position in 3D will be updated, which sometimes causes a slight jump in the data. So it's really a case of seeing if that's occurring in your data, and then possibly what I would suggest is just deleting the range like so, select, creating a nice clean gap, and then using interpolate gaps to fill. So interpolate gaps uses a average of its neighbour's position to fill the gap. So here we can see the gap's been filled. If I turn on projections again, it's been filled using an average of its neighbour's positions, like so, and it actually does a really good job. So more often than not, you'll end up relying on this gap filling solution. Okay, so that's it in terms of optimizing and cleaning your take. In the following video, we're going to look at taking your fully cleaned range of motion file and labeling a new take so you don't have to go through all these steps that we've just done. Thanks for watching, and I'll see you in the next video.